Hello and welcome to another video. In this video, we're going to be working on remove nth node from the end of the list. And it's going to be a linked list problem, and given the head of a linked list, return the nth node from the end of the list and return its head. So in this example, so the basic count, like this would be the first node from the end, the second node, the third node, the fourth node, the fifth node. So you're going to want to remove this node and return the head right over here, and that's what they did. In the second example, you only have one node, so you just remove that and you return the empty list. And in the second example, you have nodes like this, or the third example, you have nodes like this, and you want to return the last node, so you just return this node over here. That's what they show. And then n can never be bigger than the size of the list. So because you might remove the head of a list, what I like to do in most linked list exercises is make a dummy node in front of the list. That way, even if I remove the head, I still have like another node in front of it. So let's kind of draw this out and show what this is going to look like and go through this example in two ways you can do it. So let's just say this is our linked list. So we'll have 6 nodes. So 1, 2, 3, 4, 5, 6. And then we'll have like arrows from one node to the next. So like this. Yeah. So here, probably could have actually just copied like half of it, but that's fine. So let's make this a little bit smaller. All right, and last one. A little bit smaller again. Move it and move this. There we go. Okay, so basically what you want to do is you want to make a dummy node, and then you want to have it point to the head. So you can just make like a node that we're going to use. That way, if we get rid of the head, it doesn't matter. So we'll make this node that doesn't really matter, but we're going to use, and we'll put a little d over it signalizing dummy. And then we'll have the rest of these have values. So like 1, 2, 3, 4, 5. And there's kind of two main ways to do this. One is traverse the entire list and figure out its length. So we can just make like a current node. We traverse this entire list. You just say like until current's not null, add 1 to the length. So let's say we figured out this length apart from the dummy node and we know it's 5. Then if we want the nth node from the end, it's just like a simple calculation to figure out how far forward you want to go. And it's basically going to be the length of the list. So length minus n. So like in this case, the list is 5 nodes and we want the second to last, so we will just do 5 minus 2. So if we traverse, if we start here, if we go 1, 2, 3, we want to be at the node right before the one we're going to remove, because to remove a node from a linked list, you want to be at the one right before you're about to remove. And then basically what you do is you take this node's next pointer and you just have it point to this node over here. And that kind of eliminates this node. So that's kind of the idea. So you can just do that, and this will be a 2-pass solution. The other thing you can do that's a little bit tricky is actually you can just have a slow and a fast node. And they do tell you like they want you to do it in 1 pass. It's not really a 1 pass because you still like are traversing a list with 2 different nodes. So the way this works is you have a slow and a fast node, or like a pointer, and the slow pointer will start here. And then basically you want your fast pointer to keep going up a bit until like the number you are trying to get is 0. So in this case, we're trying to get the second to last node. So our fast pointer will just go up 1 value and then 2 values. It will start here. And then what's going to happen is as you move both of these nodes up, when the fast pointer is over here, the slow pointer will be right where you want it to be. So let's kind of walk through how this is going to look. So if you move them both up once, right? Let's actually just get rid of, we'll just maybe rename it to like this or something. Okay, so let's move this over here. So that's 1. Then 2, they'll both be over here. And then finally 3, they'll both be like this. And notice how your slow pointer is right in front of the one you want it to be at. And let's say we had some other value that we wanted. Like let's say we wanted the third to last node to remove, which would be this node over here. Then we would have the fast pointer move up 3 nodes to start. So 3. And now if you look, this will go up 1, 2. This will go up 1, 2. And now you're right in front of the node you want to delete again. So to do all these calculations, you can basically just like draw out your linked list, try out a few numbers, and then you can figure it out pretty easily. The second one is a little bit tricky with a slow and fast pointer, but with the length, I think it's pretty straightforward. So we'll code up the slow and fast pointer just because I think it's a little bit unique. But essentially, once we get rid of our node, so like I said, we just have this slow, wherever it ends up, we will have it point to the one after we're trying to remove. So now that this is basically gone. Because nothing points to this, so this will just be garbage collected. And this will be gone. Then we just return the node right after the dummy node. That way, even if we were deleting the first node, it would still be fine. Because like, let's say we're deleting the first node, which in this case would be the 5th to last node. What would happen here is if it's the 5th to last node, then the fast pointer would move up 5 times before we start. So 1, 2, 3, 4, 5. And then notice once again, the slow pointer is right where it needs to be. So if we delete the one after the slow pointer, so basically what's going to happen is this gets deleted. This now points to this. And now you can see that like, because we have this dummy, it's still like the head of the list will always be the node right after the dummy node. So we'll just return this node over here. And so that's what we're going to code up. So we'll make a dummy node. And I think these are super useful for linked lists or doubly linked lists. That way you don't have to worry about like, did I lose the head? Did I lose the tail? You're never going to like lose it because it's just like there all the time. So we'll make a dummy node. We have a value that we don't care about, so we'll just give it a value of 0, and its next is going to be the head. And then we'll make our slow and our fast point to the dummy. So fast equals dummy. Now, remember, our fast needs to move up n spots before we start moving them both together. So then the slow ends up being right in front of where we want it to be. So we can say like for I in range and move the fast pointer up. Now we basically just keep going until the fast pointer is on the last node. So we can say while fast next, while there is a node to keep going, for the fast pointer, we'll move them both up. So fast equals fast next, slow equals fast, slow next. So it's not really a fast pointer, it just more gets like a head start. Like they both just move up one node at a time. Now finally, we just need to delete the node right after the slow. So we just say slow.next equals slow.next.next. That will essentially get rid of the node right after the slow pointer, and we return dummy.next, which will be the new head of the list. Dummy.next. So let's take a look here. And yeah. And so for most of these, honestly, the things you have to learn for linked lists is like using a slow and a fast pointer, breaking a list, reversing a list, and traversing a list. And the problems don't really scale in difficulty. Like once you do enough, it's kind of pretty easy. The only times it gets really harder is if you have to use like a linked list as a data structure to do some other things, like LRU cache with a linked list or something. But once you do enough of these, it becomes pretty straightforward. So the time, basically always the time you're looking for a linked list is oven, like a 1 pass or 2 pass or however many passes. But for almost all linked list problems, you want to have an oven solution, and you don't want to be creating like more nodes. It's okay to make a couple, right? Just like because if you make like 1 or 2 nodes, it's still content space, but you don't want to like make a copy of the list or something. So for 95% of linked list problems, this is what you're looking for: O of n time and O of 1 space. And yeah, I think that's going to be all for this one. Haven't had a linked list problem in a while, but like I said, once you do enough, there's not really too much to practice. There's like 3 operations you got to learn how to do, and then it's pretty straightforward from there. So if you did like this video, please like it, and please subscribe to the channel, and I'll see you in the next one. Thanks for watching.